welcome back to our YouTube channel, Becoming a ROS Developer. My name is Rodrigo, and today we have one of our students, Francois, who has completed the course ROS Basics in 5 days, and this is for C++. This is one of our courses online, and it offers an online certificate. And in order to get this certificate, we require a presentation and implementation of a project on a real robot here at the construct. So that's what we're going to be seeing here today. So hello, Francois, how are you?
I'm fine. I'm ready for this presentation.
Awesome. So yes, whenever you want, please share your screen and just tell us how you've achieved the project.
Oh, disabled chair. This is
Oh,
something.
yes, let me see. Try again now.
Ah, that's pretty good.
My bad.
Should be better like this. So you should see yourself.
No, I haven't. I don't
Oh,
see your
hello.
screen yet.
Okay. Okay.
All right. Yes, I see your screen now.
Okay. So I have everything set up for this demonstration. Basically, what we have is a robot here. It is a real robot. And the goal of this project is to have the robot find the wall, then move. They make a turn around the space and stop when it is coming at the same place when it started. So I will show you
Mm-hmm.
this demo and I'll explain how the code is working. So first of all, the robot is turning slowly to find the wall. So we have a laser in there that is finding the distances around the robot, and we want to have the robot in front of the wall, which
Wow.
is the time when this distance is the smallest in the front of the robot. So here we go. We are almost in front of the wall. So we face the wall, then we go closer to the wall,
Uh-huh.
and we get the robot aligned on the right side at 300 millimeter from the wall, and it will start. Okay, so it's starting. So what you can see is that we're building a list with the various points where the robot has been, and it is the distance from the starting point. So when we're going to be back at the starting point, when we're going to get closer, this distance is going to decrease until the times that we see that we have made a full turn around
I see.
the circuit.
Okay. And then the first number is the length of the, so it's
The,
the
the
points that it's
list,
recording, right?
yes.
Okay.
So we're getting close to the end. So the distance is decreasing slowly. And then we get to this point where we are at the starting point, and we just add, we have the total length that have been
Uh-huh.
uh, parkoured by the robot, and we have the list of all the points to which to which the robot have been to.
Awesome. That was great. That was very
Yeah,
precise.
yeah, yes. Obviously, it was not always, but that is it. Okay, so here we go for the presentation. Okay, basically what I've made a spreadsheet. This is not the uh, PowerPoint presentation, but it is mainly the same thing.
Mm-hmm.
So first of thing, we had to understand the difference between the simulated robot and the real robot. And it is almost exactly the same, except that the scanner is not set the same way. Basically, this one is, when we look at this, okay, both of the laser have 720, around 720 points. So basically it's 2 points per degrees, but they are not aligned the same way. On our Wildfinder, Okay, this is first program that we have. This is a service that we call at one point. Okay, we have a multi-thread executor, and we first subscribe to the scan of the robot, and this subscriber has his own callback, so it's not delayed by other activities. And basically, we have the various orientation of the robot. So the real robot, okay, the index 180 is right to the robot, and in the simulated robot, it was the index 540 that was right to the robot. And we have in front of the robot at the 360th index of the laser scan for the real robot, and for the simulated robot, it was forward was at 0. So basically, in this, we subscribe, we get the values. Then first we find which is the minimum value, the value itself. So what is the length in front or inside or of the robot? Then we find which is the index of this minimum value. Then for the different robot, the real one and the simulated one, we have a logic that is telling us which one is forward is min. Forward is min on the real robot between 375, 357 and 363. And right is min, okay, between 177 and 183. The value are slightly different for the simulated robot, but this is the same logics. So basically, what we will return is the front distance, the distance forward, the distance at the right, and we'll have this logic is this distance the minimum for the right and for the front. Then we have our loop in the service call. Okay, basically, we have a variable that is called incomplete, that is true at the beginning. Then we have a while loop. We turn slowly until forward becomes the minimum value. Then we have face to wall that is true. Then we go to the next step. Then we move forward until last laser forward is less than 0.3 meters. Then move to wall is true, it's completed. Then we turn slowly until right is min. So the robot is well aligned on it is side to wall. Then also incomplete is false. So the loop is gonna stop. So then we exit the loop and we send the response to the client that the robot is ready to start following the walls. Is it well understood at that point?
Perfectly understood.
Okay, let's go for the main program with which is wall following. On this one, we also have a multi-thread executor. The main program, which is is running on the default call group, and the subscriber. We also subscribe to scan on its own call group. And basically, this one simply provides the distance of the laser on the side, on the right side, and on the front of the laser. Then we have a timer. The timer have its own callback group. It is canceled at startup, and it is start when the goal is accepted by an action server that I'll talk about a little bit later on, which is the odom recorder. Basically, this timer provide the twist messages based on the laser forward and the laser right values. Basically, we need to be within 0.2 and 0.3 meters it is kind of a line, it is the target line. And when the front laser is too close to the wall, we turn sharply to make the turn at the corners. Then we have the node execution logic here. So I will go that way. Okay, first of all, okay, this is the master program. So the first we call the wall service, which is going to handle the call to find wall, which is the first program that we saw. On success, basically we are well aligned. We're ready to ride around the circle on the square. So we call a program that is called we call uh, the odom action, record odom action, which is basically calculating the various distance and building the list of the points that where we have been to. Okay, then we send a call to this action server. On response of this, we reset the timer, and the timer publishes the required twist messages until we have the result from the record odom program, which basically tell us that the full turn is complete. Then the timer is stopped. We stop the motion of the robot, and we list the odom points that we've been through and the total distance. Then we shut down the program. And let's talk a little bit about this, the odom recorder, which is the action server that records everywhere that we've been and made calculation about these points. Basically, we have also a multi-thread executor. We have the main program that is running on the default callback group. And we have a subscription to odom that is having its own callback group. And basically, it is simply extracting the x actual value from the pose x and the y actual value from the pose y. So, and the action itself, basically, it is accepting the action. It is accepting the goal from the client. It is handling the accept callback. Then it is running on its own thread. Okay. There's no particular treatment when the goal is received, so it's not a parameterized goal. It is an empty goal, so just start. So we initialize the variables that are required for the calculation and an empty array for the odom list. And while incomplete, we loop 4 times per second. We calculate the total distance and calculate send this as feedback to the main program. Then we calculate the distance to the first point. We push the values of x and y to the odom lists, and we check if the distance to the first point is less than 5 centimeters. And also we have to make sure that we have travel a certain distance at the beginning. Basically, we have been riding at least 1 meter from the starting point. Otherwise, it would be starting pretty soon, just after the startup, which would not be good. So incomplete at that point is false. We have returned to the starting position. We manage the result. So the result is sent to the odom list is sent, and the goal is succeed. So basically, this is what's happening when the program is running. So it's time for Q&A at that point.
Great. Awesome. So that was great. So first of all, let me congratulate you, Francois. Really nice project. Okay. It looks like you worked on it a lot because it went so smoothly. It's always nice to see. So congratulations. I have a couple of questions here, right, and comments if you don't mind.
No problem.
All right. So the first thing that popped out at me is you mentioned that you have a in your main program you have a timer callback which you cancel. Could you tell us how you cancel that in order when for to wait for the uh, service response?
Yes, let's go to the code editor. It is the main program real. Okay. Uh, it is real. Well, immediately after the timer is defined, the timer is cancelled here.
And then you reactivate it at some point,
Yes,
right? Once you receive
yes,
that call.
yeah. When I have this one here, okay, let me just. Where is it? Whoops.
If result get well found,
Well, found. No, it is not. Yes, well, no, it is here. Uh, Let me just remember.
I ask
It
because
is.
I've actually haven't.
Where,
Usually, my go-to is just to let it run with a flag or something.
okay, it start while following. Where is it? It is at the start of the execution, I guess. The cancel, I've canceled. Here it is the end. Okay, it is when the result is received. Response, it should be send goal. Let me just remember. Goal response. Where did I place it?
Look, timer should be working now on line 180. Oh, timer reset
Ah,
179. That's where it's at,
okay,
right?
here it is. Okay, this is what we were looking for. Yes,
Ah, okay.
yes,
Great. Oh,
yes.
that's a cool way to do it.
Yeah.
Because usually, like I said, when I do a timer callback and I don't want it to do anything, I
Mm-hmm.
just usually set a flag and just print out waiting or something. That's really nice that you did that. That's cool.
Uh-huh.
All right,
Yeah.
so awesome. And then one other question I have is so do you have any type of special controller for the movement of your robot? Because when I saw it moved, it looked very smooth, like it wasn't doing if else's. Is are you doing
It,
some sort of PD control
it,
or
it,
just
it,
if else?
no, I tried PID control, but I did not succeed very much. So it's only the logic with the if else, if then
Okay,
else.
well it's
Yeah.
very nice and
Let's.
smooth. Could we just take a quick look?
I just tweaked the parameter a few times. Took me sometimes. When you look at this, we have many tries, and also I've made
Oh, I see.
this. Maybe we should see. I have this one there. It is this. No, it is graph. Okay,
Oh,
basically
awesome!
oh,
I love
yeah,
this.
basically I logged and I tried a few parameters and found which one was kind of behaving the best way.
Uh huh. Uh huh. That's awesome. Oh, great.
Mm.
And then on that note, it's a question, which is a shortcoming of the project itself, right? Because of the nature of what we're using to determine whether it has completed a lab, which is the odometry. Uh, so you're using the odometry to make sure you have returned to that point, and at that point you close it. This isn't so much of a question, but a sort of a comment and a homework assignment, let's say. And the question be like, because odometry drifts in all
Yeah.
motors, right? So you
Mm.
will have an odometry value that if you leave the robot on for too long, it will
Mm.
eventually get lost, basically, and because
Yeah.
it's going to be drifting. So uh, I'd like to sort of
At,
leave you with the thought of how you could do this, considering that the odometry will fail and how whether you think of other ways that you could determine that that lap has been completed, which is actually what is done in.
I've been lucky with the demonstration because the odometry drift a little bit. Not
Uh-huh.
this for this times, what for other tests. Okay, so basically what I've added a second condition.
Ah,
Okay,
uh-huh.
okay. So basically, at the distance for full turn, which was about 5 meters.
Uh,
Okay, so I've added this condition a little bit prior to this. Okay, it's a little more than 5 meters. So if I go uh, farther than this threshold, and basically the distance to the first start increasing, it's a sign that I've passed the starting point.
yeah, yeah, I see. Awesome. And then basically just one last question to do with actions. Uh, so what is the advantage of publishing your odometry as an action feedback rather than just printing it out on the terminal?
Uh,
Basically, the question is, what is
wh-
the advantage of an action feedback?
okay, the advantage, it will react. Or if I just print it on the screen, it won't react when I reach my goal.
Right. Yeah, you can take different
You can take action.
action
I can take.
based
Uh, I can be action based.
based on the feedback, and it's actually one
Yeah,
of the differences between a service call and a
yeah,
service server and an action server. Yes,
mm,
that you can do
yeah.
these things.
And I would say with the feedback, it was kind of easier to debug because I knew that I was kind of getting close to the goal
Yes,
of
yes,
reaching this full circle, and basically uh, that's what I used to tweak the program.
yes. It's very important, especially in robotics, to do these things and avoid so traditional software engineering, at least in what I've seen in my experience. People do the core, let's say, of the code, and then if problems arise, then you can start adding these debugging techniques or other things like an action feedback. And I recommend always start with these things because it's going to tell you so much more information of what's happening with the robot, and then lead you to potential solutions. So that and things as simple as having a good harvest configuration, right? To visualize what the robot is seeing and to potentially spot errors that will make your development a lot less painful, basically. So
Mhm.
I just wanted to
Mhm.
mention that. And looking at my questions, that would be all. So again, Francois, a very very nice job, uh, very straightforward and precise, and yeah, congratulations, Francois.
Thank you very much.
All right. So let me go here to my screen back again. And yes, guys, this is what you can do when you take one of our courses, our online courses, and you want to obtain one of our certificates. Um, you need to take the course and complete the project and implement it on a real robot and come present it like Francois did here. So I encourage everyone that is watching to do so in order to get the most out of our courses. Thank you very much for watching. Thank you, Francois, again. And we hope to see you again for the next presentation, guys. Uh, we'll talk to you soon. Bye bye.